Let's finish off this chapter on parallel lines and proportional parts. What do you say? All right, a couple of things here. It says if the scale factor of proportional segments is 1, they separate the transversals into congruent parts. So if the scale factor of the proportional segments is 1, we're talking about with parallel lines, they separate the transversals into congruent parts. And then we have the congruent parts corollary, which states that if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off the congruent segments on every transversal. So if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So we see here in this diagram, first, we see that these are congruent, which means that EF is congruent and FG is congruent. And in a moment, we're also going to look at a triangle where we can see that the scale factor is 1. But let's move over and take a look at a couple of examples. These are coming from page 494 in the textbook, example 5. So here on this first diagram on the left, well, we can see we got 3 parallel lines, and they're intersecting 2 transversals. And on this transversal on the right, well, those are congruent. We're given the measures for that, 8 and 8. And then that would mean that these 2 segments, which are defined by 7x minus 2 and 4x plus 3, well, those would also have to be congruent, and we can find the value of x. So let's see, we got 7x minus 2, and we're going to set that equal to 4x plus 3. And we're going to add 2 to both sides. We're going to subtract 4x to both sides. We'll just do it like this for fun. And once we do over here, the 2's are going to cancel. 7x minus 4x, it gives us 3x. And then 4x is going to cancel. 3 plus 2 is equal to 5. We're going to divide both sides by 3. And x is going to equal 5/3. Okay? Not too bad. Congruent segments of transversals. These 2 are congruent. That means these 2 are congruent. We got 3 parallel lines. Now in this diagram, where we got 2 triangles, one big, or actually 3, one big one's and not even the other one's not even a triangle. We have a big triangle, then we have a smaller triangle, and then we have a quadrilateral. Okay, but these 2 lines are parallel, I'm assuming, but on the proportional parts, I do have a scale factor here of 1. Those 2 are congruent, which then tells me that since these are congruent, then these segments here must also be congruent. And let's just set those equal to each other and solve for x. And I'm going to put 3x minus 5 over on the left, since I can see 3x is greater than 2x. I like my variables on the left if I can do it. 2x plus 1. And we're going to subtract 2x from both sides. We're going to add 5 to both sides. Don't normally do it like this. You usually do that in my head, but if this helps you, please use it. And so let's see, 3 minus 2x is going to give me x, because the 5's cancel and the 2x's cancel. And 1 plus 5 equals 6. And so therefore, x is equal to 6, using congruent segments of transversals. Enjoy yourself.